Hello everyone, in this video we're going to continue our adventure with NumPy. Specifically, we are going to go over randomization, basically working with random numbers and sorting, and most importantly, Boolean masking. Boolean masking is a concept and a programming technique that is going to be very useful in this quarter and in your data analytic career if you choose to use these modules for doing your data analytics. So let's get started. So if you want to create any random numbers, the first thing you need to do is to import NumPy module. So once you import NumPy module, if you say np.random, it opens up many functions and many properties that will help you to create random numbers and work with them. So np.random, and then if you say random, basically you say I want to create 10 random numbers between 0 and 1. So it gives you 10 random numbers between 0 and 1. And of course, if you run this again, it's the the natural meaning of the word random, that every time you run this, you will get different random numbers. So if I run this again, every time I'm getting different random numbers. So if I want my random numbers to come in the specific shape and in the form of matrices, I could specify that. So for example, I want 50 random numbers in a shape of a matrix with 5 rows and 10 columns. I can specify that, and it gives me 50 random numbers in that shape. So I can rerun that again, and I will have like different random numbers, but in the same shape. And the next thing, so before we run that part of code, let me create another part here. So the next thing is randint. Randint is basically creating a random integer. So basically, when you say randint 5, you say I want randomly create a number between 0 to 4. And the chance of getting 0, 1, or 4 are going to 0, 1, 2, 3, and 4 are going to be equal. So if I run this, I will get one of these 5 possible outcomes. This time I got 0. Next time, and this time I get 2. But let's take a look at it, do a for loop and see it for ourselves that, roughly all of those outcomes have the same chance to be created. One cool challenge that I will make you guys go through it is going to be sort of count the numbers of time that, for example, in this 100 random numbers, 0, 1, 2, 3, and 4 has happened. Statistically, if these are true random numbers, we want those numbers of time to be very close. And statistically, again, the higher you create, the more numbers of random, the more number of times you create random numbers, the closer these balance is going to be. So I'm going to, one of the challenges that you will see in this week is going to be doing that and seeing that for ourselves. That actually is going to happen. As you increase the number, that balance is going to become closer and closer. But let's continue. The next randomization that we have is something called permutation. So permutation is basically a type of randomization that you want to have all of the 0 to n-1 numbers in an array, but you want their orders to be completely random every time you run this. So if I run this every time I run this, I will get a different order. So let's go ahead and do another loop here and see how that might look like. So I'm going to do a for loop. Let's create like 10 permutations. Well, I think 5 is enough. And for us to see what's happening, we need to add the print here. So let's run this, and we see in all of these permutations, all of these outputs, the 0 to 9, all of them are present, but they have been shuffled. Permutation is extremely useful when you want to create random solutions for different mathematical or different optimization problems. And that's one of the key functions that for those optimization problems they're using when they use those types of optimization problems. Lastly, before we move on to sort, you can create any types of random numbers with any distribution that you want by Python. So for example, if you want a random numbers with the normal distribution of 2 and a standard 10 and a standard deviation of 2, you can just like create that, and that's just going to be very simple, just typing up the code and doing it. And you can see every time you run this, you will get a different random number. So let's continue to sorting. Sorting is, as the name suggests, is basically sorting an array based on the relevance of the numbers to one another, how greater or smaller the numbers are to one another. And so once you do sort, we make sure that the higher number or the lower number are at the front of the array, and the the other ones is at the end of the array. So for example, let's create a random number list. So we're creating a random integer between 0 and 100, and we want just 10 of them. We say size 10. And once we sort this, the outcome of this is going to be the same numbers here, but the numbers are sorted. And that's a very useful function. Imagine you didn't have this function. You would have to come up with your own function of doing this sort, and this is just like at your disposal to use, which is very useful. As we said before, if you want to create a descending sort, unfortunately NumPy doesn't have that function, but it shouldn't be a concern to us because we have that very cool slicing technique that reverse a array for us. So if you want a descending sort, so this is ascending sort. If you want a descending sort, we sort it descendingly and then switch it. So now we have ascending. So let's take a look at it here. So once we run this, now we have ascending sort. Perhaps even a more important concept than just sorting is sorting by indexes. So when we sort an array by arg sort, so let's take a look at it. So let's see, we sort this array. So once we sort it, we have these values here. But if we sort it with arg sort, what we get is basically a series of index. And that series of index is going to help us to sort the array. So we create sort of like a, middle step to get to what we want. Well, a lot of times we do want that sort, that's what we want, but a lot of other times we want the indexes. And in those times, this is a very useful function. But let's print index and see what really that is. So we say index, and now I can see that the smallest number in this array, so let me actually print the array as well, print the array itself, print the random numbers. So I know the smallest number, so this is the random numbers, this is the array, this is the indexes, the sorted indexes. So it tells me that the smallest number is in index 4. So if I count, it's 0, 1, 2, 3, 4. So this is the smallest number, and it's at that location. And then it says the second smallest number is at index 8. So this was 4, 5, 6, 7, and 8. And this is the second smallest number, and so on and so forth. Arg sort are very useful when you want to sort another column based on the sorting of another column. There's an example we'll see how it can be beneficial in data analytics when you have arcs. And finally, we arrive to the last and most important part of this video, Boolean masking. Boolean masking, as the name suggests, it's a mask. It's a mask that you have for an array. If your array has 10 elements, your mask is going to have also 10 elements. And it's a Boolean mask. So basically, it's going to be having 10 elements, 0 or 1. So let's take a look at it and then we'll talk about it more. So if I create a Boolean masking of random numbers, want to know what numbers are greater than 50 than this array that we had. So once we run this, the Boolean mask is giving us a true or false array. Basically, the elements of the array are true or false. So it's true if that element is greater than 50, and it's false if that element is smaller than 50. And it is very useful because just like a mask that you can put against another elements to sort of like let things pass or not pass, you can use Boolean masking in the same way. So for example, if this is my Boolean mask and if this is my array, so let me sort of put them next to one another so it like helps us with the understanding. So here, so now that I have the Boolean mask, if I say random numbers Boolean mask acts like a mask. It allows the values that have true in the Boolean mask to pass, and it holds the ones that are false. So for example, it will hold 25, it will hold 45, it will hold 38, but it will let 78 pass. So once I run this, it acts as a filter to my random numbers. It will only allow the ones that are true to pass. And it's a very useful function, useful programming technique that we will see many examples of how useful it can be throughout this course.